Welcome to the ELECTRO-MASTER channel. In this video, I'll show you how to create a simple LED flasher circuit. We'll be using a 12-volt DC relay, a 1000 microfarad capacitor rated at 25 volts DC, and a 12-volt DC power supply. I'll guide you through the steps to assemble the circuit, explaining each component's role so you can see how it all works together. Alright, so here's a closer look at our 12-volt DC relay. Now, a relay like this acts as a kind of electronic switch that we can control with a low 12-volt direct current, DC, signal to operate much higher powered circuits without directly handling them. So, if you want to control a larger circuit safely, relays are perfect for this job. Inside this relay, there's a coil that creates a magnetic field whenever we connect our 12 volts DC to it. This magnetic field then pulls on a small metal arm inside, called an armature. As this arm moves, it opens or closes electrical contacts, which lets us connect or disconnect parts of our circuit. Think of it like flipping a switch on and off, but instead of using your finger, we're using electricity to do the work. What's really cool is that there are two types of contacts in here, normally open, NO, and a normally closed, NC. When the relay is off, the NC contact is closed, and when the relay gets power, the NO contact closes instead, making the switch. This flexibility lets us easily control different types of circuits depending on whether we need them on or off by default. Relays like this are super useful in automotive electronics, like in car lights and horns, and even in home projects where you need to control bigger devices or appliances without dealing with high voltage directly. They're also popular in industrial setups and automation because they keep the control circuit and the high-power circuit separate, making things safer. So that's a quick look at what a 12-volt DC relay is and how it works. Here we have a 1000 microfarad capacitor rated at 25 volts DC. A capacitor like this is essential for storing electrical energy in a circuit. The 1000 microfarad rating shows its capacity to store a significant amount of energy, while the 25 volts indicate the maximum voltage it can safely handle. In our LED flasher circuit, this capacitor will help control the timing, meaning it will influence how often the LED blinks. Alright, now let's identify the pins of our relay using a multimeter. First, we'll locate the pins for the coil. To do this, I'll set the multimeter to measure resistance, then place the probes on different pairs of pins until I find two that show a resistance reading. These are the coil pins, which are essential for activating the relay. Next, let's find the normally closed, NC, contact. With the relay unpowered, I'll test the remaining pins until I find a pair with a low resistance or continuity reading. That will be our normally closed contact. This contact is in the default closed position, meaning it's connected until the relay coil is energized. Now, let's sketch out the relay pins and coil to make things clearer. First, I'll start by drawing the pins on paper. I'll label each pin as I go, so we can easily see which ones belong to the coil and which ones are the contacts. Next, I'll draw the coil itself. This is the part of the relay that gets energized when we apply voltage, creating a magnetic field that moves the internal contacts. By looking at this simple sketch, it's easier to understand how the relay's internal connections work and where each component is located. Next, let's sketch the normally closed, NC, and normally open, NO, contacts of the relay. I'll start by drawing the normally closed contact, which is in a connected state by default. This means that when the relay is unpowered, the circuit remains closed at this point, allowing current to flow. I'll label it as NC so we can easily recognize it. Now, let's add the normally open contact, or NO. This contact is in an open state when the relay is unpowered, so no current flows through it. However, when we energize the relay's coil, this contact will close, allowing the circuit to complete. By sketching both the NC and NO contacts, you can see clearly how they function differently depending on whether the relay is activated or not. I'm connecting the capacitor with the positive lead to the common pin and the negative lead of the capacitor to one of the coil terminals. I'm connecting the common pin of the relay to the other end of the coil. Now I'm connecting the common pin of the contacts to the normally open NO pin. Next, I'm going to connect 4 LEDs in series to the NC pin and the negative terminal of the capacitor. Finally, I'm connecting the 12-volt DC power supply as follows: the positive wire to the NC pin and the negative wire to the negative terminal of the capacitor. I'm connecting the power supply. As you can see, the LEDs have started to blink depending on the charging and discharging time of the capacitor. So, to summarize everything we've done in this video, we've successfully created a simple LED flasher circuit using a 12-volt DC relay, a 1000 microfarad capacitor, and a few basic components. We've learned how the relay works, how to identify its pins, and how the capacitor controls the timing of the blinking LEDs. It's a great example of how we can use basic electronics to create something fun and useful. If you found this video helpful, don't forget to give it a thumbs up, leave a comment below with any questions or thoughts, and subscribe to the channel if you haven't already. I really appreciate you watching, and I'll see you in the next video. Thanks again.